Hello guys, this is CodeNCode and this is the video editorial for the problem Totient Extreme taken from SPOJ. So the problem is we are given Q query. In each query we are given an integer n and we have to find this. Basically run a loop from 1 to n, and for each I run a loop from run a j from 1 to n, and then add totient of I into j. Totient is Euler's totient function, totient of I into totient of j. So this is what we have to print, and if I show you, this is the problem. So there are like 50 test cases. In each test case n can be as large as 10 to the power 4. So if we take an example, here's the example from the from example test case of the problem. So there are two test cases. First, n is equals to 3. First, phi of 1 is equals to 1, phi of 2 is equals to 2, and phi of 2 is equals to 1, and phi of 3 is equals to 2. Now phi, or Euler's totient function, I've already explained in the previous lectures of number theory. So if you have no idea, just go and watch the lecture before continuing here. So for n is equals to 3, what we have to print, the total sum is going to be phi of 1 into phi of 1 plus phi of 1 into phi of 3 plus phi of 1 into phi of 1 into phi of 1, phi of 1 into phi of 2, and phi of 1 into phi of 3. Similarly for 2, phi of 2 into phi of 1 plus phi of 2 into phi of 2, and so on. So this is the overall solution for n is equals to 3. So if you evaluate this for taking phi of 1 is equals to 1, since phi of 1 is equals to 1, and phi of 2 is equals to 1, and phi of 3 is equals to 2. If you evaluate this expression, the overall result sum would be 16. Same for 10. So if you try to suppose n was given to be 5, so this would be the whole sum. Now see, in the first row, if I explain this, if I take it as row, this as second row, and so on, there are 5 rows. So if I consider this as first row, you see in all of the terms phi 1 is common to all of these, right? So what we can do in the first row, I can take phi of 1 out of the expression, and then the whole expression would become phi of 1 plus phi of 2 plus phi of 3 plus phi of 4 plus phi of 5, and so on till n. N here is 5, that is why we are going till 5 only. Similarly for second row, you can take phi 2 out, and what you are left is again the same thing. Similarly for third, fourth, and fifth row. So inside the brackets, what we are left with is sum of all totient from 1 to n for the input n. Now let's say sum of all totient from 1 to n is x. So all of the expression inside the bracket I can replace with x, because all of them are same. So it would be phi of 1 into x plus phi of 2 into x plus phi of 3 into x, and so on till phi of n into x. Now among all of these, we see x is common now. So we can take x out, and inside the bracket what we are left with again is same thing, that is sum of phi from 1 to n, which is again x. So the overall result is x into x, that is x square, where x is sum of all totient from 1 to n. So our result would be for n, our result would be sum of all totient from 1 to n multiplied with sum of all totient from 1 to n. So this is our final result. So to solve this, of course there are t test cases, and each test case we are given n, and n can be as large as 10 to the power 4, right? So what we would do, as we have studied in the number theory lecture series, how we can generate all of the totient, all of phi from 1 to n using sieve. That is what we are going to do. After reading t, what we are doing, we are calling the init function. Init function is what? It is going to generate all of the phi from 1 to 10 to the power 4, because in the input n can be as large as 10 to the power 4. So max is 10 to the power 4. We are initializing all of phi to be I. This is nothing but using using sieve to generate all of phi. I've already explained how we do, so I'm not going into much detail. So what we do, we run a loop from 2 to max n, which is 10 power 4 by the way, and if phi of I is equals to I, which means I is a prime number, so for all multiple of I, what we do, we divide phi of j by I and we multiply phi of j by I minus 1. I have already explained all of this thing. So finally, after running all of this loop, now what we have, phi of I contains, of course, phi of I, right? Now, since for each input n, we want sum till n, sum of phi till n, not phi of n. Remember, x here is sum of phi till n, not phi of n, right? So what we want sum of phi till n. So what I'm doing here is that we are taking prefix sum of phi function. So phi of I initially was equal to phi of I, of course, but after running this loop, that is, we are using prefix sum here. So phi of I now, phi of I is actually sum of phi from 1 to, of course, phi till I. So now if input is n, we can directly print phi of n into phi of n. Again, phi of n is not equal to phi of n, but sum of all phi from 1 to n. That is what we wanted. So this would be our result. So this was how we solve this problem, Totient Extreme from SPOJ. So this was all for this lecture. If you have any doubt or query, of course you can ask in the comments. So thank you guys for watching, and until the next video drops, keep coding. Thank you.